Hello everyone, it has been a while since I made the last video, but I've been thinking about building a bigger rig than my Dell R730 server with two NVIDIA P40 GPUs. So as you guys have seen my previous videos, I had this server, but it only gives me about 48 gigs of VRAM. And yes, I'm using the word only over here because once you get spoiled with using a lot of VRAMs, then you start thinking how can you get more and more VRAM, and you get VRAM hungry, which is the state in which I am. And after using 48 gigs of VRAM, I was able to load 70 billion parameter models, but I wanted to do a little bit more than that, and then I went on a hunt of getting some 3090s, and I was able to grab 4 NVIDIA 3090 GPUs. So one is in my main machine, and then I have 4 extra. So yes, I have 5 NVIDIA 3090 GPUs. So I needed to install it on a machine that would be doing justice to these 4 3090 graphics cards. So with a very simple calculation, one NVIDIA 3090 uses 16 PCI lanes. So you would in general need a system that is able to support 64 PCI lanes, and if not 64, then at least 8 PCI lanes per card, so 8 times 4 32, or you can have 16 8 16 8 combination, so 32 plus 16 or 48 PCI lanes would be nice too. So many of these Intel processors, consumer grade Intel processors that I've been using, they have either 20 or 28 PCI lanes, and remember that those PCI lanes are also being shared with other hardware that you have, like your NVMe drives and stuff. So I wanted to see what else is out there that is still consumer grade, not server hardware, that can do the job for me. And I landed on Threadripper processors, first generation Threadripper processors that have 64 PCI lanes. That is insane. And the price of these processors is also quite cheap, right? And this is also very nice to have. So if you go on eBay and you look for Threadripper processors, and I find that 1920X is that sweet spot that doesn't make the processor cost very expensive, and you can grab a 1900X. And a good thing is all the three processors, 1920 and 1950, all three of them have same TDP, and all three of them have 64 PCI lanes. The only difference that you'll see is in the core count and thread count. So 1900X is 16 cores, 8 cores, 16 threads, and 1920X is 12 cores, 24 threads, and 1950X is 16 cores and 32 threads. So if you are looking for a lot of multitasking on your server, you can go with that. But I would say for an AI server, 1900X is more than sufficient. I went with the middle option, 1920X. And the reason being, if you choose the 1920X, it actually gives you a very decent price, like $100 over here. But when you jump to 1950X, it kind of jumps way more for the amount of cores that you are getting. So yep, you can get away with 1900X too, and it is a very, very, very good price over here for 1900X, and you might find some other deals on eBay. But just looking at some of the deals that you see for 1920X, if you search, I think that $120, between 110 to 120 is a sweet spot. You can grab that, or you can always grab, like a bundle deal with some motherboard. Assuming you're buying the processor separately, you'll also need a X399 motherboard over here. And an X399, the one that I got was MSI Gaming Wi-Fi Pro AC, I think it is called. Let me look that up for you. MSI Gaming X399 Wi-Fi. I think it also has in its name or something like that. Yeah, Pro Carbon AC. Actually, this is the one. And this is a pretty cool motherboard. It has, if you see, reinforced except and whatnot. Yeah, it has reinforced PCI slots, and this has the configuration of 16, 8, 16, and 8. And it also has these X1 slots for PCI if you have some other hardware to plug in. You get 3 M.2 NVMe slots. That is pretty cool. And you have a bunch of SATA ports over here too. I don't think you'll need that, but it's all available if you want. A huge socket, TR4 socket in the center. And this is amazing. This is where you slide in your Ryzen processor, and you may want to watch some of those Ryzen 1900 processor installation. If you're buying it separately, motherboard and processor separately, then definitely you need to watch some of these, because this is slightly different than how you would install a regular processor. So you open these screws in a particular order. And these are all labeled, right? So you open these screws in a particular order, and these are special, screws over here. These are not your regular screws. So you'll have to find the right screwdriver also, which comes in the box for the processor, but you can buy them separately as well. I mean, it comes with the adequate torque in the screwdriver and all that. So just be careful. I mean, if you're buying it separately, keep all that in mind. Watch some YouTube videos on installation of your Ryzen processor in your motherboard. But this is pretty good motherboard. I really like this motherboard. I mean, I don't care about all this RGB and lighting, but the carbon fiber on this looks very nice. And then I love the functionality of having all the reinforced PCI slots, make it look really beefy. It has 8 RAM over here, slots over here, and I think it supports quad channel RAM, if I'm not wrong. We can double check that later, but I have only utilized 4. So if you are using four slots of RAM, so one will go in here, another one will go over here in this slot, third one will go over here in this slot, and fourth one will go over here in this slot, right? So you will leave the first and the third on both sides, and you will populate second and fourth on both sides. So that's the RAM configuration that you will use, or in other words, A2, B2, C2, and D2 configuration. If you want to look at the motherboard manual, that is what it will look like. So I populated all that, and I went with this $399 option because this is future proofing also. If you wanna get a 2990WX processor, let's say, that will also fit in this motherboard, but I don't think you'll ever need that. So let's just skip all that. You can just get any X399 with 4-slot motherboard, and you can get a Ryzen Threadripper processor 1900X series, and then you'll be golden over there. Once you have your motherboard and processor and RAM installed, you will also need a special CPU cooler. So your regular CPU cooler won't fit. So you see these slots over here, this 1, 2, and 3, and 4 over here. These 4, these are quite farther away. So you need to install, like a bracket, a CPU bracket, CPU cooler bracket over here and over here, and then you install a long CPU cooler on it. And those CPU coolers you can also find on eBay, and you can look for TR4 CPU coolers. So let me show that TR4 CPU cooler, and TR4. Oh, that looks ugly. Yep, this is pretty nice. Well, you see it says no mounting hardware. Be careful, you do want the mounting hardware, because without that you won't be able to install it. Threadripper TR4, yeah, this is nice. If it comes with the mounting hardware, then you're fine. So you see these 2 screws. This is nice that they have it. Let me see if they also include the base plate that needs to go over there, because without that, I don't see it. So you guys have to be careful that whether Okay, so maybe you can buy it from Amazon, or you can make sure that the TR4 CPU cooler that you buy comes with all the hardware. This is not it. TR4 liquid CPU cooler. Let me show you this if I can find the hardware that I'm talking about. Well, this one doesn't show. I'm not saying it doesn't include it, but it doesn't show it in the pictures. Let me see. Let me make one more attempt before I give up, so that I can at least spot. Oh well, this is nice too. I don't know if this is meant for TR4 or not, but that's what you're looking for, a TR4 platform CPU cooler. Yep, this is good. This is good. Let's open this. $65 and I don't know if it comes with this. But there is a bracket also that goes underneath there. So what I'm talking about is that that bracket installs on the motherboard. Where is it? So you install the bracket over here on this and a bracket over here, and then you put the CPU cooler on the top, and the bracket provides you with two places in which you can screw the CPU cooler in. And I can see these two pins. You see first pin over here and second pin over here. These two pins go inside the slot provided by the bracket. So whatever CPU cooler you buy, just make sure that you have the full kit. Don't buy half kits like this, and that won't work for you anyway. So you'll need your motherboard, CPU, RAM, CPU cooler, and NVMe drive. Obviously you will need your power source. So this needs two CPU connections over here, one motherboard connection, and I don't know if you guys can see it, but there is another PCIe connection over here. So because each one of these, they're designed to take in your 4 graphics cards, right? So each one of this needs 75 watts of power being pushed through this. So they have very nicely provided another source of PCI power input that can power these 4 slots over here. Very nice thing for MSI to do that. So all right, let's go into some of the software sections of it. So now that you have built your machine, the very first thing, close all these things over here. So all the evil links I'm going to close. And now that you have set up your hardware, your next step is you need some kind of operating system in your machine. And we'll be using Ubuntu server for this, not the desktop Ubuntu, but Ubuntu server for it. So you will get the server install image and you will burn it onto a USB drive, and then you will take it to your physical machine, install your server, and there are tons of guides for 2204 Ubuntu server installation. I don't need to go in there, but assuming you have installed your Ubuntu server, right, you have to enable SSH while you are installing, and you need to know the IP address of your machine. So for my machine, the IP address is linked to the name server configured in my pfSense firewall, right? So when I type AI, then it automatically resolves to 192.168.1.10, which is the static IP address I have given to my machine. So what I'm going to do is I'm going to open any terminal emulator, right? So I have a WSL on my Windows over here. You don't need WSL for it. I just happen to have WSL over here. I'm going to use that, but you can SSH into your new server, right? So my server is 192.168.1.10. I can use that, and you can do yes. You want to recognize the fingerprint, and then you want to put the password in here, and you are in, right? So you are in your machine. You'll see that the domain name for my machine is AI. And let me show you something else. I'm going to exit out of it. And I will show you that this domain name actually resolves. So if I do a ping on AI, it says that that is the 192.168.1.10. So what I can do is I can do SSH AI and it will SSH into my machine like this also. But you saw that I had to enter the password every time and I don't like that. So what else we can do is we can copy our SSH credentials into the machine directly, so that you can when you are using SSH, you do not have to type in the password every time, right? So the way to do that is you can generate a key. You can generate a SSH key pair, and you can use the SSH keygen command for it. So SSH. So all this assumes that you have keygen. And yep, home Mukul SSH ID RSA is good. Empty no passphrase is good. And it has been created, so that is good. And now what I can do is I can copy the, so let me just see if this thing actually got generated. And in order for me to do that, I can, this gets generated in your home directory. So you can do lsla home directory slash .ssh, I think. SSH, yep. And yep, there you go. So it generated your ID RSA public key, which is what needs to get copied over into your remote machine. But there is an easy command to do that. You do not need to manually copy it. There is a functionality that gets provided. So this SSH ID is for your Ubuntu machine, right? So this is for the WSL that I'm in right now. So this, whatever I'm doing over here is for WSL. So if you are on the Windows, you can do the same thing for Windows and copy your SSH key pair from your Windows machine, right? So what I need to do is SSH copy ID, and you can type the username at AI, right? So Mukul at AI, this is my username, at AI is my remote machine, and it will now copy the SSH key into pair into SSH key pair into the remote machine, right? So this is the username and remote host, and I'm gonna hit enter, and it will attempt to copy it, and it will ask for the remote machine's password, and you will provide the password and it will copy it over there, right? So now what you can do is just try SSH AI, and I don't need to enter password anymore, and I will be able to log in from this machine directly. Let me demonstrate that to you again. I will exit out of this altogether. I'll reopen my Ubuntu terminal from local. So this is WSL, and I will do SSH AI, and boom, I'm logged in without any trouble. Okay, so now that I have my SSH into remote machine working, I want to first set up basics of what I usually do for any machine, right? So first of all, if this is an AI server, right, what you need, number one, is NVIDIA drivers. And let's see what machine we are having. So uname-a gives you your machine details, right? So this is an AI remote host. It is called AI, and it is a Ubuntu machine. And these are some generic kernel details that you have over here. So what you want to do over here is you want to see whether NVIDIA drivers are installed or not. So let's try that. NVIDIA SMI, right? And it says, whoop, it cannot be found. So there are no NVIDIA drivers installed over here. So what we want to do is we want to see, let's see, NVIDIA devices. Oh, the command not found. Ubuntu drivers, GPU. That doesn't work. Ubuntu drivers, devices, and it should show me devices that it detects. Let's give it a second and let's see what it comes back with. So it has found some NVIDIA devices over here. So definitely found the 3090 GPU that it is connected to. And it is saying that, yeah, it is there, but you need some drivers to be installed over here. So before we install drivers, I'd like to install webmin over here. Webmin gives us a very nice interface. So we are looking at, you know, like a terminal over here, and terminal is very nice, good, fine. But sometimes we do want to use a webmin interface, a web interface, so that we can see more details. And in order for us to do that, let's go ahead and install webmin on Ubuntu 22.04, right? So let's just do a sudo apt update and let's have it update. And then we will run these couple of commands that will install So we added the webmin repository. I think we did. Did we do the next line? Yep, we did. Okay. And then it's asking us to add this line at the bottom of. Okay, so let's do that. Let's add this line at the bottom and Control X, Y, enter. So that has been added. And then sudo apt update and sudo apt install webmin after that. And let's do a yes. And we'll have our webmin installed after that. And webmin runs on 10,000 port, easy to remember. So once this is done installing, we'll quickly open the port 10,000 and we'll take a look at our server details and some configurations. All right, perfect. So let's go over here. So AI colon 10,000 and let's go over here. And it uses the same credentials as your login credentials for your machine, right? So Mukul and whatever your password was. So you use that credential and you're able to log in. And now you have a nice interface that you can work with. All right, so it's asking to update the webmin repo, which we will do now. And it's saying that there are some updates that are available that we will update in a bit. But let's take a look at what webmin interface provides us. Let me increase the font size over here. Okay, so it says you have no CPU workload, almost no workload over there. And this is the RAM that is being used. This is the virtual memory. This is the disk space. So this is pretty nice. What I usually like to do is I like to change I'm looking for changing the drive. Yeah, there it is, partitions and local disk. So you see it is a 2 terabyte disk that I have. And what I want to do is I want to extend the slash volume, right? I want to extend this completely. Logical volume management, probably it is over here. Yep, it's over here. It wasn't in the other section. So if I go into this particular volume, well, it automatically says size is located 100 gigs out of 1.81 terabyte, whereas I want to increase this to 1.81. How do I do that? I believe I need to go to the logical volume, click on this, and click on use all free VG space. And just do a save over here. And now I have 1.81 terabyte allocated. Perfect. So now I won't have the problem of not having all the space that was allocated to my machine. And let me see, does it say local disk space 86 gigs used and 1.7 terabyte free, and it says 4% disk space over here that is used. Perfect. This is where I want it to be. Using Webmin, it becomes very easy. Let me change to the dark mode. I like the dark mode over here. And let's also, while we are here, click on these package updates and see what updates are available for our server. And you can always run like a sudo apt update, sudo apt upgrade to do all this too. And you can also do that using this nice interface that they have provided. You know what? Let's go ahead and let's do update selected packages, and let's update all these packages that are available over here. And Webmin will run these commands in the background. I think it just does a build of complete list of packages first, and then it will let you click on install now, and then you can install this. So it just kind of refresh the whole thing, and now you can click install now, and it actually installs everything for you. So we'll let it do this, and once this is done, I'll show you a couple more things in Webmin, and then we can jump directly into installing NVIDIA drivers on this machine over here. So this may take a little while because there were a few packages that needed to be installed. So let's see. I mean, it is 1920x. Oh wow, okay, all right, and that was pretty quick. So return to the packages. And probably there shouldn't be any packages anymore. And what we'll do is we come back over here and we'll take a look, and all packages are up to date, which is what we want to see. All right, so if we go back, there is a tools terminal section, right? And this is pretty cool. Like if you want, you have access to a terminal right here. So you can just open a web interface and you can come to this terminal section from here on. Even from your phone, you can just open this particular web interface and then you can navigate to terminal section. I find this tool very useful. This terminal emulator over here very useful. Again, if you are looking to upload and download some files to your machine, you can very nicely navigate using this interface and upload and download some content over here. So you can upload to a server, and you can also download from server. You can choose a file and you can download from the server. So it gives you a nice interface to navigate. So let's see, if I want to go to my home directly, I can go to home, and then inside home there is my name, and then if there was a file over here that I wanted to add, download, I could have just clicked on that and then selected it and then clicked on download, and it will download this file on this machine. Pretty cool, pretty nice thing to have. Before we proceed, I always recommend installing Webmin so that we can monitor the system while we are doing other things over here. Okay, next step. Closing this, closing Webmin installation. Now installing the latest NVIDIA drivers, CUDA actually on Ubuntu 22.04. To do this, we need to first see which NVIDIA graphics card do we have, right? So let's clear this. We can do lspci grep NVIDIA. So we have 4 NVIDIA graphics cards over here. If you see, we have 4 3090s connected to this machine, right? So this just shows us that we have to install graphics card drivers for NVIDIA graphics card for us. And if we run NVIDIA SMI, you will see that there is NVIDIA SMI not installed. And what I would like to do is install the latest graphics drivers and not the 551 that's mentioned over here, right? So if you see, there is NVIDIA utils 535 and 550 mentioned, but the one that is available on the Ubuntu's on the NVIDIA's website is 555, which is the one that I want, and that's the one I will be installing. So just using these commands over here to proceed further with installation. And these commands were all on the NVIDIA's website, and I just copied them over here for easy reference in my local repo. If you see, this is again a locally hosted Git version where I put my local Git repositories, and this just makes it easy for me to reference all the installation guides that I have to refer to in future. So just makes things a little bit easier for me. So just running these commands one by one and installing the latest CUDA version. Here we go. And it says that it's gonna need about 4 gigs of data to download and install. Let's say yes to it. And while it's installing, let's take a look at what webmin says. That is it even feeling any load? So barely. Our system is barely feeling any load over here. It's pretty interesting to see. Well, most of the resources are busy downloading, so let's see if there is a network IO. Yep, so network is spiking. CPU is feeling almost no load, it's almost just sitting idle at 0. But yep, we do see some network, some disk, input output. Let's see some network interfaces if there is any details. No, nothing much. Disk usage is mostly free. So recent logins, login from this machine, so that is nice. It shows that. But it's mostly just pointing out that it's downloading right now, and it's downloading at a pretty nice speed. So that's pretty cool. And once it is done downloading these packages, and it is done installing all these packages, then we'll be all ready and set for our very first AI application that we will install over here, which is going to be OLLAMA server, our favorite OLLAMA server. So we'll get OLLAMA up and running, and we'll install OpenWebUI that will get up and running, and we'll allocate all 4 GPUs and we'll see the performance of that. But you know what, I actually have a 1600 watt power supply connected to this particular system, and 1600 watt may not be sufficient. However, we do not have to limit ourselves to 1600 watt well, we do not have to consume all the 1600 watt, essentially, is what I'm trying to say. So what I'm going to do is I'm going to set up power limit so that we can set up each GPU to not consume more than 270 watts of power. Let's do that first. And then we'll make sure that all 4 GPUs can at the max consume only 270 watts of power, so that they are not just sucking in extra power for no reason. And I know I'll probably lose some token per second due to this, but I'm okay with that. My main use case is to have a ton of VRAM and just do not exceed the power beyond a certain limit. So 270 times 4 is going to be around just under 1100 watts for me, which is what I'm looking for. So 1080 watts of GPU at the max load, and then there will be a motherboard, processor together pulling in maybe 150, 200 watts. And I'll never be loading both CPU and GPU at the same time, and that's where I'm estimating I'll be around 1300 watts if I power limit all the 4 NVIDIA graphics cards to 270 watts. So once this is all done, this is when we will be able. So you see how the network has dropped. So it means it's not downloading anymore. It is just doing an IO operation right now. So this is maybe CPU may spike a little, but I don't see any spikes in the CPU, which is all right. I will, however, restart the server after the drivers are installed over here. So let me do that once the drivers are completely installed, and reboot this server. But I can also maybe before I'll see. I'll run a NVIDIA SMI command, and if that works, then I'll also power limit, and then I'll go on to rebooting the server. Let me just double check that. Let's wait for this to finish installing. And almost done. Which services should be restarted? So let's come back over here. Let's restart all of them. And let's do NVIDIA SMI. Okay, so it definitely needs to restart. So let's do a sudo reboot, and let's wait for it to reboot over here. All right, so the machine, let's see, let's ping the machine. And let's see if it is up. So the system has come up now. Very nice. 2 milliseconds of response. Very cool. And we can SSH into the machine also. And uptime, yep, it has been up. So all nice, cool. And we can refresh our dashboard for webmin, and everything looks cool over here. Everything looks nice. 32 gigs of RAM and all that, everything is up. And we can now run NVIDIA SMI and see what it looks like. So we have 1, 2, 3, and 4. Wow, 420 watts of max power draw. So if you add all this up, this is a lot of power to be drawing from the wall at its peak load, and we don't want that. So what we're going to do is we're going to create a NVIDIA power limit service, and let's do that then. So let's create NVIDIA power limit service, and we'll create it in EDC systemd system, and what we'll put over here is we'll create a unit of work, right? And we will create it as a service. So, and then what we want to do is as type, one second, let me just double check over here that the recording is on. Okay, all right. So we'll do type as one shot, and what we want to execute is the NVIDIA SMI command, but we want to locate where that NVIDIA SMI is. So let's do this. Oh, one second. We don't want this. Let me start a new Ubuntu shell, and we can SSH into it, and we can do where is NVIDIA SMI, that is in user bin NVIDIA SMI. Okay, so what we can do is we can take this user bin NVIDIA SMI, and then we can power limit it for first GPU power limit to 270, right? That's what this particular command says. And then we can copy and paste this command let's copy it and let's paste it 4 times, and let's modify the GPU numbers over here. So GPU 1, GPU 2, GPU 3, and GPU 4, right? So 0th is the first position, then 2nd, and 3rd, and 4th. And if you want to see where am I getting those numbers, oops, clear, NVIDIA SMI. So you can see the GPU numbers are right here. So once we put all 3 GPUs, power limit it to 270, and we do it at the start of our system boot, then we'll be easily able to limit the power for all these GPUs, right? And then install, and we will do wanted by as a multi-user dot target. Okay, so this should be it. So we have a unit, set NVIDIA GPU power limit as a description, and the service is type one shot, and we have 4 commands: NVIDIA SMI -i, first GPU power limit to 270. We copied this over for 4 GPUs, and we are saying just install this one. So now Control X, Y, and then save. And what we need to do is reload the systemctl daemon reload, right? So we'll reload the systemd manager configuration, and then we will enable this particular service that we have just created. So in order to do that, let's just enable this service, and after we have enabled it, we can start the service immediately, and service has been started. And if we rerun this particular command, so I'm going to run this over here so we can see the difference between these 2 screens. So NVIDIA SMI, and now you will see that all 4 are capped to 270 watts, right? So instead of 350 watts, 370, and all those random manufacturer defined, well, not random, but manufacturer defined numbers, you are power limiting each GPU to its max capacity of 270, which is a very nice, middle ground that you have for each GPU. All right, so now that you have all 4 GPUs in place, you have CUDA version 12.5, driver version 555. Over here, you have the latest and the greatest software to begin with. Now, at this point, what I would like to do is install Docker for our system, right? So the best way to do that is just go Docker on 2204, and Docker's guide itself is pretty cool over here. So let's, oh, no, not the DigitalOcean, but the actual Docker guide. So the Docker documentation is pretty good. And I like installing it from here. So let's go over here and let's choose the Ubuntu documentation. Okay, so this is it. We will copy this. Just want to make sure that there is nothing that talks about. Okay, so yep, OS requirement 2204 LTS. Okay, all right, perfect. So this is what we want. Run the following command to uninstall all conflicting packages. We don't have to worry about it. We do not have any conflicting package over here. Just a fresh install of this machine, so we'll be all right. So I'm going to copy this command over here and paste it right here. So actually we don't need 2 terminals. I'm going to close one of these terminals and just keep one up. Let's copy this again and paste it. And once it is done, then we can install the latest version of all these Docker Compose plugin and Docker over here. All right, specific version. I don't need any specific version. I just need the latest Docker over here. So let's install the latest Docker. There's a lot of data to be downloaded. That is fine. And I'm surprised by how low the CPU utilization is. It's really amazing. All right, so all that is installed, but I won't run this sudo docker command over here because I like to do this post install step. So let me do the post install, and in the post install, this don't need to be run. This group is already there. I'll run it anyway, but you'll see that the group already exists. You can add the current user, right? So $user is the current user. It will add a current user over there, and then you can apply this group membership right away, and you can run a hello world now. And it doesn't file the hello world locally, so it downloads it and it will then run it, which means that your Docker is up and running and all is good. Okay, perfect. So this is a very nice way of running all of our AI applications by using the containerized way of deploying applications in your AI server that you are building. Now let me go to OLLAMA and let's install OLLAMA on our machine, right? So, and we want the Linux way with the Docker image to run OLLAMA. So let's do that. So I'm gonna open this, and we want to make sure that we are having the NVIDIA Container Toolkit used over here for installation, right? We are using NVIDIA GPU. We are not using the CPU option, and we'll be using this. So let's do this, and let's see if NVIDIA Container Toolkit is installed. Or NVCC. So it is not installed. It says it can be installed with this command. So let's take a look at it, and we can see which version of this toolkit will be installed over here. So it says version 11.5.1 if we go with this route. NVIDIA CUDA 11.5.1. I see, okay. All right. So I think what we are missing over here is there is NVCC already installed in this particular location for us. So USR local CUDA bin already has NVCC installed for us, right? So we have NVCC over here. It's just that it is not in our system path. So what we have to do is, I think if we put it in our bash RC, right? So bash RC, then at the bottom of this file, we can add a couple of lines that will actually add our CUDA 12.5 to the path, right? So we have exported path this to our system path, and let's do a yes, enter, and then let's just source this bash RC, and let's do a exit, and let's do actually an exit again over here, right? And let's do well, we didn't have to source if we were going to exit, but I just want to do anyway. And let's do NVCC, and now we see that we are having a 12.5 over here. Right. So I don't think we have to install the NVIDIA NVCC or container toolkit and all that. That was already installed for us. What we do, however, have to do is configure Docker to use NVIDIA driver. So what we can do is, let's see NVIDIA CTK. Let me see if it is even there. And it is not. So let me take a look what's going on. All right, so even though I have NVIDIA CUDA and NVCC installed, I don't think I have NVIDIA Container Toolkit installed over here, right? So if I do a show for Container Toolkit, I see that I still need NVIDIA Container Toolkit installed over here. So what I'm gonna do is I'm just gonna go ahead and I'm gonna go ahead and install it. I'm gonna go ahead and install it the way that they have been asking us to install it instead of following my own approach. So let's do that. Let me go ahead and install it the way the OLLAMA recommends. And let's just do a show again and see what it says now. So it still says the same. Let's do an update just to make sure that it did actually do an update. And let's go ahead and install this. All right, now that it is installed, let's do just to make sure that is still correct. Yep, so that is right. And let's see if we have the NVIDIA CTK over here. Yep, we have NVIDIA CTK also. So this is the container toolkit, NVIDIA container toolkit, version 1.15. All right, so we have it. Now that we have the NVIDIA container toolkit, we can configure Docker to use NVIDIA driver, right? So let's copy this and let's do this. And now it is asking us to restart the Docker container, which we have done, but we'll do that again. And we have restarted the Docker container. And this is where this command will now download our OLLAMA's latest image, and it will run it. But I like to optionally add an extra parameter over here. So I think it is restart always, like that, and we can double check it. So I believe it is just like that, restart always. Yeah, so that is like that. It'll just every time when you restart a system, in a way, you know, when Docker engine gets back up, it will automatically run this particular image for you, right? So I'm gonna hit enter over here. So what's all it is doing is it is saying that, hey, use all GPUs that are available, right? We are not saying that only use 1 or 2 GPUs for this purpose, but use all the available GPUs. Do a volume mapping. So in our case, we have 4 GPUs, right? 4 3090s. Do a volume mapping of OLLAMA to root.ollama, so that after the OLLAMA server restarts, it can persist the data in your local volume, which is named as OLLAMA. And then the port mapping is 11434 standard, and it's just mapping back to the host port over here. And we are saying always restart when the Docker engine restarts, and the name of this particular image will be OLLAMA, and you can find it as a tag of OLLAMA/OLLAMA from the hub, Docker hub over here, right? So let's just hit enter, and obviously could not find OLLAMA locally, so it will go out, download OLLAMA now, and it will install it for us. Right, so OLLAMA is here, and after OLLAMA there is a OpenWebUI that I really like to install. So OpenWebUI, let's get that, and there is a GitHub page for it too. I hope it takes me to the GitHub page. It don't really matter. We can actually install it with this command, because this is the same thing that the GitHub will do. So all we are doing is we are just taking the 8080 port from the Docker's exposed port and mapping it to 3000 port on your local machine. So Docker run in detached mode, port mapping of this, and you're adding the host.docker internal host gateway so the Docker can access your local machines, hosts, and ports. Volume mapping again as OpenWebUI, and internal folder is this one, so it can persist the data after it restarts. The name is this, and wow, so they have already done restart always over here, so you don't have to add this flag. And this is the image that it will download. So this is pretty cool. I'm just going to copy this, run this, and this is actually, I think, a pretty big file. I think it is about 1.5 gigs if I'm not wrong. Yeah, 1 gig over here, and then several other downloads. I mean, I think together they are 1.5 gigs of download. And you can see like the system is barely, it is barely facing any load. So that is amazing. It's a very efficient processor, just not facing any load at all. I really like this. Okay, all right. Oh no, failed to register the layer, invalid tar header. Okay, you know what? Let's just run it again and let's have it download again. Probably it couldn't download it right, or something happened during the download. Let's see. It should be able to get it back, and hopefully it will not face that invalid tar or archive while extracting it. And once it is done, we will download a couple of models over here for us. We'll download a simple model and we'll see what token per seconds that we are having. Okay, so we are done. We are done over here. So now we can just go to 3000, and this is now being rendered by our remote machine. What I'll do is I'll do a watch one NVIDIA SMI, and what this command does is it's going to refresh the NVIDIA SMI command every 0.1 second. So you will see on the fly what is the statistics of each graphics card that is attached to the system, right? So let's see that. I do not have an account yet. So this is running from the OpenWebUI that we just ran in our Docker, right? So we are running that, and it's asking us to first create an account. So our very first account needs to be very carefully created because this will be your system account. And got it. Okay, let's go. And this is your system account. And the very first model, like if you want to see what all models you can download, you can go to OLLAMA.com and their library. And so if you click on these models, you will see a list of all these different models that are over here. And we're going to get a few of these models. But let's just get the 27 billion parameter Gemma 2 model. I really like that model. It is really nice model, and I want to get the bigger one, right? So FP16, instruct FP16. Let's get this model, 54 gigabyte of model. Let's get this. You know what? Let's get a simple model first, so I can show you guys what it is. So the best use case to show is Llama 3. Everyone wants to see this model, so let's just show the simplest model over here, Llama 3, right? So let's go over here, select a model. If you type Llama 3, then it will pull that model from OLLAMA server, and you will see, let's see, the network tab being used over here, and it must spike up now. So the network is spiking up, and disk IO is spiking up too. That's good to see. Let's see, the CPU is barely doing anything. Very nice. All good so far. What I actually want to see is the very first load of the model in the GPU memory, because that is where the PCIe lanes comes into picture, right? So fast PCIe lanes means that all the model, boom, in one shot gets loaded into your GPU. And when you are switching between models, all that becomes kind of fast. Okay, so it's verifying the digest and everything is successful. All that is good. So now you can go in and select a new chat, choose the Llama model, and overcome procrastination. Yep, let's just give me the tips. And let's see how fast the model loads, right? So to keep a look on the right side over here. So I'm going to send this. And this is where the model, whoa, look at that. Look at the speed over there. Okay, so we had 93 tokens per second. That is pretty fast. That was a nice speed over here. So let's ask it, generate a snake game in Python. And because the model is already loaded, so it doesn't take it at all, no time needed at all for it to start spitting out the answer. And again, 88 tokens per second, very fast speed. Okay, so that is for a very simple model. Let's we have a 70 billion parameter model too, but I don't download that. I actually want to download some other Gemma modeler or Coin 2 maybe. Mistral, yeah. Mistral is only 7. I want to get this 27 billion parameter model and the FP16 instruct version of it, because that is 54 gigs. So this will be a very good use case to show. So let me copy this. So this is what we want to copy. And we're going to go over here and we'll say Gemma 2, but not the regular one, colon, and this particular version of Gemma 2. So this is the quantized version, but FP16 is a higher precision than normal, right? 54 gigs means this will take some time. This is not an easy model to download. So this will take some time. What I'll do is I will pause the video over here so that we don't just keep on looking this slow download, and then once it's complete at 100% and it does the SHA verification, then I will come back over here. So just keep an eye on this time. It is 5:32:48 server time, and once the download is done, we'll come back and we'll take a look at it. This will also show you how long it took to download it. All right, so it says 100% now over here, and very soon it'll finish the SHA verification, and hopefully we'll be able to run and load this model. And this will be a very good use case because 54 gigs of VRAM means that 54 gigs of model means that it has to be loaded across more than 2 at the bare minimum GPUs, if not all 4 of them, right? So okay, there we go. The model has been successfully downloaded, which is a good news. And this is one of the things, like how it doesn't go away right away. Okay, and now let's choose this model, and let's open a fresh new chat over here. Let's choose this model and let's see how fast it loads in our GPU, because that initial load time is something that is very important. So let's explain options trading using this model over here. Okay, so the request has been sent, and you can see the model is attempting to be loaded, and wow, that was pretty fast load on the GPU. So this is where all the 16 PCIe lanes came into picture, and all the 4 GPUs with 13 gigs of VRAM have been utilized. Let's see if this is the final load or not. Or maybe this was the initial memory reservation, right? Because that was very fast. That was very fast. I think that was the initial memory reservation. And by reservation, I mean kind of allocation, and then it is gonna actually populate it because I don't see the results yet. Yep, now it got loaded. Okay, it did take some time. It did take some time. Okay, so let's see. I see the tokens per second is still pretty good, right? I mean, for FP16 model, it is very decent. And you can see a total of 60 gigs of VRAM is being utilized over here. Right, so this is where the power of 96 gigs of VRAM kind of is coming to picture. Let's see. We got 13 tokens per second, which is decent, quite decent for a FP16 model of 27 billion parameters, right? Let's get some other models in. If we get the regular 27 billion parameter counterpart of this, it should not be a problem. So these are usually 4K quantized. I'm pretty sure this is 4K. Yep, Insta Q4. So this is the 4 quantized 4-bit, not 4K, 4-bit quantized model. And we can actually get one of these two, but instead of that, I'm gonna go and get a Quen model because that's also pretty cool. So let's go and let's get the Quen model and DeepSeek Coder V2. This is also pretty good model that I use all the way across for all my coding initiatives. So let's get the Quen 2 though first. And Quen 2 72 billion parameter, that is what we need. And this is a hefty model, 41 gigabytes. So we won't be waiting and watching that. Quen 2 and 72 billion parameters. I believe that is what it was, if I'm not wrong. Let me double check. Quen 2 72B, yes. Okay, so this is gonna take some time to download too. And while this is downloading, I'm gonna pause the video and I'll resume it again once we are at 100%. While this model is downloading, let's see if we can see some other features of this OpenWebUI. So if you click out of it, it doesn't stop the model from downloading. It just, kind of puts it in the background. So don't be worried if you clicked out of it and that window went away. So what I like in this newer version of OpenWebUI is that you can actually, so let's say if I choose this, right? And if I say hello, it loads that model. So there are, you see these three servers have 15 gigs, and this now, instead of having 15, it has 21 gigs over here. And it's 21 gigs because this one has not only the 15 gigs, just like the other ones of the partial FP16 version of Gemma 2, but it also has the Llama 3 loaded over here. So Llama 3 just needed a little bit more and it got all of it loaded over here. So if I ask this question again, you will see that only this particular GPU where Llama 3 is loaded will be spiking up, right? So you see only that GPU spiked up. Now, if I click on this plus icon and if I choose the second model as Gemma 2, now both the models are loaded, right? So if I ask it a question, tell me a joke, right? Then you will see that both the models get a chance to reply back. And if you take a look over here next time, then you will see that that all the GPUs are kind of spiking up, with this one having more load over here, right? So let's see this. Write a Python program for snake game, right? And both the models will compete, and you see how the processing on this one is huge because it is having both Llama 3 and also Gemma model over here, and the Gemma being a little slow because it is a higher precision model. It is slowly making its way it's trying to finish its task over here. But pretty cool thing to see. If I maximize the screen, maybe it will look a little better, maybe not. So let me go back to the same screen size and let's hit escape so we come back, and you can see that all these GPUs are working towards giving us an answer, and hopefully this is a better answer. I mean, obviously that's the reason why one would expect that it's taking time. It's a 27 billion parameter model also, so hopefully it is thinking more than a regular 8 billion 4-bit quantized model. Again, it is 27 billion and FP16 model versus this is 4-bit quantized model. So obviously it's taking a lot of time to do that. I also want to install a 4-bit quantized version of the regular Gemma 2 27 billion parameter model, so you can see the difference in speeds of the quantized models and all. Okay, so it's definitely spitting out more details, and I haven't run any of these models, so I do not know, but let's see. Once it's done, we can take a look at the tokens per second. So for our generation formation over here, we had 69 tokens per second. So that drastically fell down because both the models were working together. Let's see this one, and this is at 13 tokens per second, right? So this stayed almost the same over here. Let's see if our Qwen 2, oh yeah, it's downloaded at 72 billion parameter models. This is one of the bigger models. Again, 4-bit quantized though, so definitely at precision it is little less, but again 72 billion at 4-bit quantized is a huge model for us, you know, to play around with. Definitely it will be better than a 27 billion parameter model, but I have seen that the Gemma 2 27 billion 4-bit quantized model has exceptionally good function calling capabilities, and I'll be making some videos around that too. But it has exceptionally good function calling capabilities in my testing. So we have this Qwen 2 downloaded and running. So if I choose this right now, and let me remove all the models, and I'm just going to choose this, and if I ask a question, I'm pretty sure these models will get kicked out because there isn't any space remaining on the VRAM. So I think it will detect that it has to kick out some of the models, and let's see what happens. So yep, it detects that there is no space remaining, so probably it kicks out some of the model. Okay, so it kicked out the model that was taking most of the space, and it left the Llama 3 in there, and that was nice. Okay, and it is loading the model, we can see, and while it is loading the model, CPU is barely spiking. That's expected. And let's see. Wow, you killed the joke. Okay, 17 tokens per second. That's decent. I mean, I've seen up to 23 tokens per second, but then given that we have power limited our GPUs too, I think this is decent. 17 is good enough. It's quite good actually. So let's ask it to Python game in, oh, let's see what it does in Snake. Let's generate a Python game in Snake instead of a Snake game in Python. Let's see. Oh yeah, that fixed it. Okay, it's doing its best to generate the game, and there's an option to run this code too, and I don't know what that does. Was there an option over here? That's an OpenWebUI's functionality, looks like. Okay, all right. So let's see, once it's done, I'm just gonna click that button. I've never done that before. Let's see what it does, and we'll find out. if it kind of opens up a shell or something over here, or if it tries to run it in the main terminal, it kind of kicks off some kind of terminal. I mean, it being a web browser, I doubt it'll have access to run Python code straight up from here, so I don't know what it'll do. But let's see. If I click on run, what happens? I do, however, want to get the Gemma 2 27 billion, which I'll kick off. Gemma 2 27 billion parameter model. Just like this while it is. Okay, let's click on run and see what happens. Running. Interesting. Oh, so it is running using the code runner and trying to run this, and obviously found some errors and issues. All right, that's fine. Okay, so let's see the tokens per second. Again, 16, 17 tokens, which is all right. And I think I get about the same tokens per second with Llama 3 70 billion parameter model too. So in terms of, like where we stand with these models performance, we are kind of landing in the same spot. The only benefit that we get is huge amount of VRAM. So 24 times 4 is 96 gigs of VRAM, which is huge. So I'm just gonna have this Gemma 2 finish as well, because this is something that I really like for all my function calling needs. Actually, there is Mistral model 2, that Mixtral model that I like to, for the fun of it, you'll try the Phi's tiny model, so 4 billion parameter model, the 2 gigabyte model, and see how fast that runs. And let's see if there is any recent model that has come out. Whereas instead of feature, let's do the newest. And oh yes, Llama 3 Grok tool use. This is actually, I was reading about it a couple days back. And this is actually a very good function calling model. I actually definitely want to get this in the 70 billion parameter of this instead of the regular Llama 3 70 billion parameter. So, let me get this. Definitely, I want this one. So once this is downloaded, which is done, I will get the, come on, go away. Thank you. 70 billion parameter version of this. And this has been known to be very good with the function calling, and I haven't tested it. I just saw and read about it that it was competing with one of the few of the commercial models and outperforming, and it could be possible that it is overtrained on that data set. So it's skewing towards that, but I definitely want to test in my use case for function calling to benchmark it against the other models like Gemma 2, because as of now, Gemma 2 has been a superhero model for me for function calling. So nothing beats it. And let's see. So let's go to the regular Gemma 2 27 billion instead of the FP16 version of it. And this is relatively small. So you'll see that the same task, if I regenerate using Gemma 2, it will get loaded in the memory first. And whenever that is done, it'll come back and start outputting. So just waiting for it. Okay, there you go. So by looking at it, all the GPUs are being utilized. And let's see. Pretty good speed for 4-bit quantized big model. So I like that. And let's see, 32 tokens per second. I like it. I actually like the speed. It's pretty good speed. Let me try to regenerate it. I saw some of the models got kicked out. So let's see if that affects the speed at all, because right now this is the only model that's loaded in the memory. Pretty cool. It is detailing out the game over here for us. Now let's try to run this also once it is done. Okay, it's done. Let's see if it runs. Again, some kind of error. That's fine. It outputted something. It attempted to output something. All right, so enough credit to the model. This will take some time. I don't think we'll wait for this. Anyway, so let's summarize. So we built a system, a Linux system. We installed webmin on it. We installed NVIDIA drivers on it. We also installed CUDA drivers. Then we installed NVIDIA CUDA, NVIDIA Container Toolkit. And then we installed Docker. We enabled Docker to use NVIDIA GPUs. And we installed OLLAMA server, and we enabled OLLAMA to use all 4 GPUs. We also power limited our GPUs to 270 watts. And we eventually installed the OpenWebUI. And via OpenWebUI, we downloaded a few models, we benchmarked them, we saw how fast the models are getting loaded in our 3090s and the PCI lanes, extensive number of those available on our Threadripper 1920X and X399 platform, how it helped in loading the models very fast on our GPUs. All right. I will follow up with some function calling tutorials and function calling videos and benchmarking that I will do. So please keep an eye out for those videos. Thank you everyone for watching this one, and I will see you in the next video.